grab?
Yeah, fairly large.
This. What's the value last time?
Everybody sign in? Sign in?
Yeah.
And then you can have your pencil back.
That's not my pencil.
Okay, so CAD design. 3D design of a robot to your exact specifications. More or less. Depends on how good you are. And practice over time makes good. Because perfect is the... What's your slogan? Perfect is the enemy of good.
Perfection is the enemy of good.
Oh, that's right.
So, the design process, think, draw, CAD, build. So that we don't waste all of our money trying to buy materials and then do the wrong hole and buy the exact same material again. We CAD it so we know what we want to do before we do it. That's basically what this is saying. SolidWorks is the one we use in this school. Do you accept Google Draw?
No, Google Sketch. No, it's an Autodesk Pro. No,
anyways, SolidWorks is fairly hard. Miss Willingham used to do CAD professionally. Not sure if it was her job, but she was, yeah, so part of her job. She's hosting trainings in 317. We'll probably go down there and see what she's doing. I looked for last year's robots CAD design, which I spent a lot of time on, and apparently it disappeared, so darn. It was a full mock-up of the robot that we used, of the Frisbee bot that we used for the office here already. First and second steps, first of two steps, sorry. The first step is the part. You have to first make a part, like a piece of metal, that will go into your build step. So, first you make a drawing, literally like a square, or a circle, or an octagon, it doesn't matter. And then you extrude the base, which is taking that square and elongating it on its side. So you just took that square and made a cube, basically. Then, you take that cube and you save it.
That's what it says.
Yeah, you have to open a whole nother program now, a whole nother screen. And in that screen, you have to take the part and put it on your bit on your to your where is it? Project. Once you put the part onto your project, you still have your part, but you can put multiple parts onto that project. So you go through, you make all your parts in different pages, then you take all those parts and you put them onto one screen.
I don't know.
Yeah. Mating is the technical term for taking two parts and going like this to them. Now they're stuck together until you either delete that mate or you leave it there.
That's where you cross your fingers.
Hi, this is Miss Willingham, everybody. Anyways.
I was wondering if there's any veterans down here who were missing my CAD classes.
Oh, I did it last year, so. Yeah.
No CAD class today?
Oh, well, we'll come over there. Since today is basically the CAD training, could we come over there and see?
Yeah, nobody's on the computers.
Alright, perfect. So, a little bit of vocab. An extruded cut is when you have that 3D design, just takes the hole out of it. Extend base, I already talked about that. The axes are important if you want to use the 3D printer. Because if you have your build, say, on the computer, it looks like it's up and down, but the axis that you have it on would be like this, then the printer will print it sideways and it'll come out all weird. Like a phone case. Normally you would print a phone case with the back like this. If you have it built so that the x-axis is this and the y-axis is this, then it's going to come out like that. And the 3D printer will print a bunch of supports to try and keep it standing out. It's not going to come out pretty. It's going to come out like this, a jumbled mess of nothing.
It's a waste of $2.
And it's a waste of $2. project and part, those are just the two different screens that you can use to build. So yeah, let's go. I wanted to go see what she was doing, so let's go over there.
What? Do I have to bring this?
You can.
Let's.
But you don't have to.
Oh, it's over?
Yeah, technically, this part.
Technically.
Center lines to start with, because then you have references to your origin at all times. That way when you start to make assemblies, you have some references to build on to help mate things and constrain it. So, and the other reason here, if you notice, his that he drew is blue right now. So that means it's not constrained in the X or Y axes. So it can, in theory, change dimensions without you changing dimensions because it doesn't have constraints in the X or Y. So that's, again, why I recommend you start with center lines.
Which is also why I use that.
So.
There'll be a day when I need people to do lawns and geometry work next summer for my business.
Make it 2x4. Yeah. Like a piece of wood. So this is called Smart Dimensions. You can basically put in whatever number you want, but it normally goes by, whoops, that's not what I want, inches. You can put in centimeters or anything else, and really it'll convert it. Wow. I keep forgetting how it'll convert it back to inches. So.
You have to change your dimension type in the bottom.
Yeah, you have to go to
left-hand corner,
options.
or bottom right-hand corner.
Oh no, you can type it in, just 50 cm, and hit enter, and it'll make it 50 cm, but it'll say it's 19.69 inches.
Okay. So, if you look here, my drawing here has been fully dimensioned, and it's turned black now. So, if I change things, it's fixed in this location right now. And so it'll change things according to how I fixed it in that location. So if you leave it blue, wacky things may happen when you start moving things. So you should always make sure it's black before you start making it 3D. So when it's in 2D, make sure it's black before you move on.
Right? There's M.
Alright.
There's A. This is net of.
So then you go back to features, and that's where extrude the base is.
So this is a net.
You can extrude it however much you want. I'm going to go like 5 feet.
A true 2x4 goes 16. Or, sorry, 8.
Now you have a 5-foot 2x4. And you hit done, which is right there.
Up or down?
Oh, by the way, if you press down the middle key, you can move around.
Rotate.
Yeah, rotate your view.
And if you hold control in the middle, it slides in.
Oh.
And if you roll the ball, it'll zoom. Zoom wherever your arrow is going to be the center of the zoom.
What's the tension of the
Let's go back. There we
No,
are.
it's already
And
tension.
there's our original square.
Tension's already negative, so you want to get no tension is by itself. So yes, subtract the weight from both sides.
Forgetting how to move it.
Okay. And then divide it by -1.
Oh, what was that?
This is your feature. So
Oh.
you can pick the side you want, or the angle you want to look at it from.
Wow. This one.
Yep, that one.
Oh, yeah.
Up in the top right.
Plug in.
There you go. You can pick from the sphere how you want it to be.
What?
Is that new?
That's,
That
yeah,
was my
that's,
last year.
I was
Yeah,
gonna
that's
say,
new.
I didn't use that last year.
so there's your, wow, yeah, that's awesome.
That's convenient.
Very convenient. Alright, so now you must save this piece as whatever you want to save it as. Let's just say part 1. See, I had all these other parts from last year.
Don't they get deleted at the end of the year?
I don't know.
Or is that on your file?
And then you have to open up a new assembly. And we'll just bring in 2 of the same parts. Yeah, and make them. And insert component. There. Now we have 2 of the same parts on one view. Alright, here comes the fun. Yay. Now we get to make them. And you...
Make an assembly?
Yeah. I started them. She extruded her cut straight through the middle of her board.
I made a shell.
Yeah.
I'm flavoring. Okay.
Alright, so now we get to mate, which is this little paper clip right here, which is where all the fun comes in. So you can mate in many different ways: parallel, perpendicular, coincide, tangent, tons of different fun stuff. But for now, we'll just do, most likely it'll turn into parallel. But you click the two surfaces that you want to mate. So, let's go back, let's move back. So I click one of these walls, and, wow, too close. And then another one. And they slide together for me, which is really nice.
You have to mate in multiple spots in order to get it.
Yeah, and in order to get it flush,
Or locked. Okay, then mate at least 3.
You have to constrain, and it's not
There
just
you go.
any 3. You have to constrain it in the X, the Y, and the Z.
yeah.
And if you're not sure if it constrained, you can grab it and move it around. And if it moves, you haven't fully constrained it. Unless you want it to move. Like if it's a wheel, you might want it to spin. So you were not going to fully constrain it.
Oh, I'm still in mate, that's why. There we go. Now I can. Actually, I can't move it. Which is what she was talking about, the wacky stuff happens.
Yeah, and sometimes it will. It'll just randomly flip it and spin it and do weird things.
Control Z.
Okay, apparently I have another part on here too. That's a little bit weird. Did I accidentally move these? Because that turned when I moved it. See how it's doing that?
SolidWorks tries to think smart, so you kind of have to.
Alright, so I can see right here, over here at least, move this down, or not, whatever. Let's open up mates. So there's my mates, and you can see where everything is. So apparently, via this mate, I have these two edges stuck together. So let's get rid of that one. Yes. Now I can move this without it wigging out. But if I wanted to... Hold on, let's get rid of all of these, and we'll make like a box.
So, okay, before he does it, if you have a part open and an assembly open, you can take your part and drag it over there.
Why didn't I teach us this?
Okay?
So much easier.
You can drag it over there. You can also do, they have a thing called Smart Mate, and sometimes it'll try to, you can drag it over where you want it to mate when you drag it in, and it'll try to guess how you should be made. So I'm
Oh, that's my original, so let's get rid of that. And we'll insert another part. Alright, that onto that. Enter. Oh yeah, if you hit enter while you're trying to make stuff, it'll just finish it by itself. Yeah, it can also do some stupid stuff like close your program if you're on the wrong thing.
So if you see here, I can move this, I can spin it, because I haven't constrained it. So that's one way to check if you've constrained it right. You want to see if it moves and if it spins. So right now, all I've done is said that these two holes should be lined up. That's all I have right now. So let's say I want to make...
Yeah, or aluminum or whatever you want it to be. Are you going to make the two circles together?
Alright, again.
Oh.
She's just a step ahead of you, that's why it spins.
Okay, so now it just spins. So then to make it not spin, anybody have a guess on how we would make it not spin? Constrain it how? Where should I constrain?
Two adjoining faces.
Which ones?
Could you let some... You already know catting.
Where should I
I
constrain?
have my phone.
So if it spins right now, what should I tell it should be?
If we want it to lock up.
So I've told the holes they need to be in the same
Parallel.
same axes, yeah. And then I've also told it that these two beams should be a certain distance apart. So now it spins. So this one spins. So how can I make it not spin? What do you guys think?
Like the two smallest size line up.
So make the two ends line up? Okay. So I'm going to zoom in here.
You can get to really, really small dimensions. Like, this is,
Come over here and I'll say this face.
that's how instant it is.
I want to let me do this. It should have worked.
What I hated when I started doing this is you scroll up to go out,
Oh yeah, I got lost so bad.
and you scroll
Isn't there like a center button?
in.
It
Oh,
is.
maybe, yeah,
It's
make it
in the
parallel.
view panel.
Yeah, yeah.
Like,
There you go, because it says coincident.
there you go. Nice.
And if it lined up the wrong sides, you can have it flip them. Right now it's doing opposites, and here it does same. Okay, so now that I say okay, and I can grab it and it won't do anything. Okay, so that's how I know I've been successful.
This is how you figure out where you want your bolts, where you have to drill, because we would have to drill this hole out with one of the drills we have over there, and we don't want to have to drill 3 holes in one spot to get one bit in. It'll make it inaccurate and very unstable for us.
Because they said it could be positive.
And a waste of.
And a waste of material if we have to redo it. So, yeah. Anybody want to try it?